So, now that we've reviewed what polymorphism means, and we've also described in general what a visitor can do, let's look at an example of using a visitor to solve the problem of separating behavior from structure. So, assume that we have a structure such as this. A structure with an abstract type of expression being either a compound expression, addition or subtraction, or a number or a variable. So simple expressions such as numbers or variables, or compound expressions such as sums or subtractions. Now, as a brief example, we construct an abstract expression using a chaining of constructors, so a sum being given operands in the form of a subtraction and a sum and so forth. We simply use this expression to print it, and let's look at the results. So 1 minus x plus 5 plus y. 1 minus x plus 5 plus y. Okay? Now, these classes have yet to do anything meaningful. For a compound expression, we can print it, and depending on if the left and right operands are compound expressions themselves, we print them within parentheses. For simple expressions, we print integer values, numbers, and we print the names of variables. That's about it. If we want to extend this structure with new functionality, such as obviously calculating the result of an expression, then we'd have to add functionality to all these nodes. Also, if we want to traverse this structure and understand bindings to variables, the current bindings of variables, we'd have to traverse it and make sure that we extract all the variables and obtain their values, or their names if we want their names. So for each type of behavior that we want to add, we'd have to add methods to many of these classes. We might imagine that this structure is developed in one place and the types of behaviors could add is developed somewhere else by someone else. So a solution then to separating structure from behavior is to introduce the visitor. We've already prepared for this by having a method called accept, and the idea is that we implement the method accept on all nodes where we want to make the visitor see this type of expression. So we have an abstract method accept here, which is implemented in the class number, variable, sum, and minus. Let's look at an implementation of an accept method. It calls a method on the visitor with the current object as its argument. Let's look at what this method visit in the visitor, what that looks like. Notice here that just as in our example with polymorphism, we have a number of overloaded methods visit that take concrete classes such as number, variable, sum, or minus as their parameters. And we call these methods from the respective classes. So in the class number, we call the visit method which is overloaded for numbers. In variable, we call the visit method which is defined for variables, and so forth. So this is a way of making sure that the visitor visits the right type of object. Whenever we add a new type of expression, So assume we add multiplication as a new type of compound expression. We'd have to add an accept method to ensure that that node 2 can be visited by any visitor. So what can a visitor do then? Let's look at a test. We already saw that we could print an expression. That's the result of printing an expression. But we can do the same thing, printing, by having a visitor. Though we're not always guaranteed that we will have the same results there. Let's look at what the difference could be. First, we print an expression using a method defined on abstract expressions. Or rather on the runtime type of this expression, which happens to be a sum. Now, what about the print visitor? Why is the result of printing with a print visitor different? So here we print 1x minus 5y plus plus. We print the same expression, but in postfix format. So operands first, operator later. Look at the definition of the print visitor. It simply prints that which is specific to each type of node. So a number is printed with the number's value, a variable is printed with the variable's name, sum with a plus and minus with a minus. But and all nodes are visited by this expressions calling the appropriate visit methods here. But the way in which compound expressions choose to call these methods and recursively call accept methods of operands is not defined by this visitor. So this visitor doesn't know when this visit method is called, or indeed what responsibility the visitor has here, because we could imagine that a visit method for a sum is made into a more intricate method. So we might dissect x dot left operand and do something with it. So accept this visitor. Maybe we do that first and then we write operand dot accept this. If we do this, of course, since the operands are already displayed, we'd have them displayed twice. Would probably become rather messy, like so. And the responsibility then would be unclear. Is the visitor responsible for calling accept methods, or is the visitor only responsible for calling the X object to obtain something that it can print in this case? Well, a visitor is usually defined so that it's only responsible for receiving calls and obtaining values from the node that's currently being visited, not traversing compound type expressions. So if we go to another visitor which counts variables, it's only interested in one type of expression. So variables lead to a counter being incremented, all other expressions are simply ignored. If we go to our example here, we can see that using a counting, or rather we do like this. So let's see what a counting visitor does. We construct our expression and then we accept the counting variables visitor, as an argument to the accept method. And we print the number of variables by asking the visitor, once the expression has been traversed, what's the number of variables? There were 2. So now we looked at a print visitor, and in the print visitor it was obvious that when printing or when doing anything with an expression, it's not defined by the visitor how the compound expression or the tree of objects in general is traversed. So the visitor is at the mercy of individual type expressions. Now, we could of course change this so that we call the visit method and the accept methods on operands in a different order. So instead of calling the visit methods last, resulting in a postfix notation from the print visitor, we could visit in infix order, that is, between the left and right operands, resulting in a printout that reads almost like the original one, apart from the parentheses around compound expressions. As a last note, if we look at the definitions of the accept method and the sum and the class which is for some reason called minus, see that they're suspiciously alike. So we accept a visitor to the left operand, we visit the current node, and we accept the visitor on the right operand. And they both share the same base class compound expression. So why couldn't we just remove this, go to the compound expression, and implement the accept method here? Now it says that the visit method is not applicable for the argument's compound expression. So what could we do? We could create a method visit with compound expression as its argument. But we also have definitions of visit overloaded for sum and minus. Remember our example with polymorphism. If we keep this implementation and we do something sensible here, like, well, this shouldn't really be used because we have these other implementations of overloaded visit methods for sum and minus, so this should result in some kind of error. Or maybe like so. Let's see what the result will be. Apart from counting variables, you also print expressions. Let's look at the example of printing with a print visitor. It's considered that 1 minus x is the wrong type of expression. Why is that? From class minus, we moved the definition of the accept method up to compound expression. We didn't do the same thing for sum. So in the class sum, there is an accept method still here. But for minus, we moved the accept method to class compound expression. And compound expression calls the visitor with itself as an argument. At compile time, we resolve this into a call of the visit method, which takes as its parameter a compound expression. Meaning that it doesn't matter that at compile time, the actual type of this will be a minus type expression, as in 1 minus x. But at compile time, we determine that there should be a visit method called which accepts a compound expression. There may be different overridden versions of visit depending on the actual runtime type of v, and we select one of those depending on the runtime type of v, which means we apply single dispatch on the recipient only. We do not dispatch at runtime on the type of parameter for the current object. So we assume that we should call visit on a compound expression. This is the reason we cannot move accept methods up in the hierarchy, but we have to keep them defined for all concrete classes. So we go back to the accept method defined in class minus, run our example, and there we go.